Look at multiplying polynomials. And so first I want to look at 3 different examples. So we're going to add 2 monomials, subtract 2 monomials, and then multiply them. And so on the first 2 examples, these are really just combining like terms. So the only reason I can add these is because they are both x squared, they're like terms. So I just add the coefficients, 3 and 2 make 5, and I keep it x squared. So notice when we're combining like terms, which we've been doing a lot of that, but when we're combining like terms, the exponent doesn't change, it stays, it remains at 2. When we're subtracting, again, that is combining like terms, so I have 3 minus 2, which would be 1x squared. And again, just like always, the exponent does not change, it remains 2. But then here, on this third example, we are multiplying a monomial times a monomial. Here, the exponent will change. So this is the only time the exponent will change if you're multiplying or dividing. So I'm going to write this out the long way, which I did a while back. But 3x squared is 3 times x, and then it's multiplied by 2x squared, which is 2 times x. So remember multiplication, I can change the order, it's commutative. So that 3 times 2 would give me 6, and x squared times x squared would be x to the 4th. So when you are multiplying polynomials, those exponents can and they will change. When you're adding and subtracting polynomials, your exponents will remain the same. You can only combine like terms. So first we're going to look at multiplying a polynomial by a monomial. And polynomial means several terms, monomial means one term. So here's our first example. So this is really an example of using the distributive property. So if I have this binomial, these 2 terms here, this negative 2x to the 4th needs to be distributed to both. So if I do negative 2x to the 4th times x to the 1, so I am multiplying, so that would give me negative 2, because really there's that 1 here, so negative 2 times 1 is negative 2. And x to the 4th times x to the 1 is x to the 5th. So now I need to distribute again. I need to distribute negative 2x to the 4th times negative 3. So negative 2 times negative 3 makes that positive 6x to the 4th. So I'm distributing to both terms. So for a second example, I have another monomial, 1 term, times a binomial, 2 terms. So again, I'm going to distribute. So I'm going to multiply when I distribute. 5 times 3, that part gives me 15. K to the 3rd times k squared. All together, I am multiplying k by itself 5 times, so that is 15k to the 5th. And I have to distribute again. You distribute to every term that's in parentheses. So when I multiply here, 5 times negative 7 is negative 35. And k to the 3rd times k to the 1, there's the understood 1 there. So k to the 3rd times k to the 1 is k to the 4th. And I'm finished. So here we have a monomial times a trinomial, 3 terms. You do the same thing. You distribute to every term until you get to the end of the parentheses and you stop. So 2m squared times 2m squared would be 4m to the 4th. And then I have 2m squared times 3m. So that would give me plus, it's positive, 6m cubed. And then my third thing I need to distribute, 2m squared times negative 5. So that gives me minus 10m squared. And I am done. So notice there are no like terms to combine, so this is my final answer, and I leave it. So here we have 2 things we'll have to distribute. So first, I'll take 4b times both of these terms. So 4b times negative 5b would be negative 20b squared. And then I have 4b times negative 3, which would be negative 12b. So I'll stop distributing because the parentheses stopped, and then I'll continue the problem here. So here I have negative 2 that needs to be distributed to these three terms here. So negative 2 times b squared would be negative 2b squared. Negative 2 times negative 7b would make positive 14b. And then negative 2 times negative 4 is plus 8. Now on this problem, unlike the previous ones, we're actually not finished here because now I can combine like terms to simplify this answer. So we'll start here, the negative 20b squared and the negative 2b squared. That is negative 22b squared. The negative 12b and the plus 14b are plus 2b. So notice here I'm no longer changing the exponents because I'm no longer multiplying. I'm just combining, adding and subtracting. And then lastly, that plus 8. And now the problem is complete. Okay, so now we're going to look at multiplying a polynomial by another polynomial, so not just one term. So the first method we're going to look at, it's called the FOIL method, and you might remember this from school. FOIL is just an acronym to help you remember. The F stands for first, F-I-R-S-T. The O stands for outer. The I stands for inner. And the L stands for last. And it just helps you remember to multiply to distribute completely. So here we have a binomial, 2 terms, times a binomial, 2 terms, which means I'll have to multiply 4 times. So I'm going to have to distribute x to both of these terms, and then I'll have to distribute the positive 2 to both of these terms. So the FOIL acronym just helps you remember to multiply 4 times. So F stands for I multiply the first term in each parenthesis here. So x times x is x squared. Then the O for outer, so I'm going to multiply the outer 2 terms, x times negative 3. That would be negative 3x. The I for inner here means I'm going to multiply the inner 2 terms. So positive 2 times x is plus 2x. And then the L stands for last. So I'm going to multiply the last term in this polynomial by the last term in this one, which is positive 2 times negative 3, which is negative 6. And so notice the x got distributed to both terms and the 2 got distributed to both terms. So here I am almost finished. It's just that I have like terms here that need combined. This negative 3x plus 2x should be combined. So I'll have x squared negative 3x plus 2x is minus 1x, and then minus 6. And there I have multiplied a binomial times a binomial. So another FOIL example, so I'll multiply the first term in each. X times 3x would be 3x squared. Next, for the outer terms, O for outer, x times negative 7 is negative 7x. Next, I will do the inner terms. Negative 5 times 3x is minus 15x. And then the last term in each parenthesis, negative 5, be careful here, it's a negative 5 times a negative 7, so it's plus 35. So when I go to simplify my answer, the negative 7x minus 15x are like terms. I need to combine them. So here I will not change the exponent because here I'm just subtracting them or combining them. I'm not multiplying anymore. So that gives me negative 22x or minus 22x. So I have 3x squared. I'll rewrite it here. Minus 22x plus 35. And that problem is complete. So I would have you try this one. I would pause the video, try, and then check my answer. So here I get 10x squared. Here I get minus 10x. Here I get minus 16x. And here I get plus 16. So I have 10x squared has no like terms, but negative 10x minus 16x are like terms, so I will combine that to minus 26x and then plus 16. And I am finished. So one of the last examples I want to look at is a binomial times a trinomial. So the FOIL method doesn't necessarily work. It doesn't make sense to say first, outer, inner, last, but you are still going to do the same thing, that is distributing. So since I have 2 terms here and 3 terms here, I'll have to distribute 6 times. So it takes a little while. So what I would recommend is starting with the negative 5x, distributing it 3 times, then go to the 2, positive 2, and distribute it 3 times. So I'll start here. So negative 5 times x cubed, or sorry, negative 5x times x cubed will be negative 5x to the 4th. Negative 5x times positive 2x would be negative 10x squared. And then negative 5x times negative 3 will make positive 15x. So I'm halfway finished with distributing. Now I need to go to the positive 2 and distribute it to all 3 terms. So this would give me plus 2x cubed. This would give me plus 4x. And then lastly, my constant times my constant here would give me minus 6. So you can see it's pretty time consuming. So now I'm going to carefully combine like terms to write my final answer. So negative 5x to the 4th. There are no terms to combine with. So then I will look to the x cubed terms. I'm going to write it in standard form as I go. So I'm looking at my exponents in descending order. So here I have plus 2x cubed, no like terms to combine with. Okay, now I'll look for the x squared terms. I have minus 10x squared with no other x squareds to combine with. Okay, we're almost there. I have positive 15x plus 4x. So I will combine those to make them plus 19x, not changing the exponent, just combining the coefficients. I'm not multiplying. And then the minus 6, and there you have it. Okay, so if you'd like to try this one for practice, and then you can check with me when you're finished. So here I have 5x. Here I have plus 3x squared. Here I have minus x cubed. Now to distribute the negative 2, so I get minus 10. minus 6x, and then plus 2x squared. You can pause it again if you need to. So now I'm going to combine like terms. I'll write my answer in standard form. So I have negative x cubed. And I'll look at my x squared terms. I have 3x squared plus 2x squared, which would make 5x squared. I have 5x minus 6x, which will be minus 1x. You do not have to write the 1. And then minus 10. So just a couple last things to look at, and that is if you are asked geometry problems regarding polynomials. So for geometry problems, you have to remember area of rectangles, you multiply length times width. So if you see an area problem, that's typically always going to be a multiplication problem. So it would mean I need to multiply those two polynomials. So when I multiply those, I would get 2x squared and then I would get here minus 4x plus 9x minus 18. When I combine my like terms in the middle here, that gives me a 5x. So I get 2x squared plus 5x minus 18. So then if you were asked for perimeter, so hypothetically, if you were asked for perimeter, I'll abbreviate there. Perimeter would mean you needed to add all four sides. So if you were asked a perimeter problem sometime in the future, perimeter problem, if I didn't have all this here, for perimeter I would need to add x minus 2 plus 2x plus 9 plus x minus 2 plus 2x plus 9. So if it were a perimeter problem, I wouldn't have x squared in the answer because I'm just adding all of those. So one last thing I wanted to remind you about and warn you about, and that is whenever you have this power rule here. So here, notice everything in parentheses is a product. It's all multiplication. This is 5 times x times x times x times y, all multiplication. And so we learned in that first chapter that you distribute the exponent there. So for example, this problem here would be 5 squared. That would be x to the 6th. And that would be y squared. And you could write that as 25x to the 6th y squared. But then what happens after we learn this rule is people will often try to distribute with a binomial like this, and you cannot do that. When there's a plus or minus sign in here separating the terms, you cannot distribute the exponent like that. It's a very common mistake. So here you can, because this is technically a monomial. This is one term. There's no plus or minuses. Here, this is a binomial. You can't distribute the two. You can't do that. And so what I mean by that is you should not get that as x squared plus 9. It's a very common mistake. And so what you do here, what you do actually do here, is that would be the whole binomial, x minus 3, times itself. So that would be x minus 3 times x minus 3, which if you want to pause it and do your FOIL and see what you get, play, that would give you x squared minus 6x plus 9. And that is the correct way to do that. Okay, so that is it for today. Good luck.